Alright, so let's go over and talk about review. Make sure we have our order of operations and simplifying down. So it does say assume variables are non-negative. We're going to talk about what that means as well. So in number 1, 3 squared plus 4 squared. So in order to do that order of operations, say exponents have to happen before addition and then the outside. So 3 squared is 9, 4 squared is 16. 9 plus 16 gives 25, so you get 5. And number 2, a negative squared becomes a positive, so you get 4 plus 64. 64 and 4 is 68. 68 is the same as 4 times 17, but 4 becomes 2, so we have 2 square roots of 17. And number 3, again, you have to square, then add, so then we get a perfect square. Square root of a perfect square is 13. In 5 and 6, we start to reintroduce variables as well as powers to powers. In number 4, you're going to do 6 squared plus 10 squared. You get 36 plus 100, you get 136. Breaking that down into 4 and 34. 34 is 17 and 2. Those are both prime, so you cannot simplify them, so you go back to 34. In the next one, you add those two together. When you have 2x squared, you bring out the x as x square roots of 2. Now, if you put absolute values around the x, that is fine. But it says the variables are non-negatives. So what that means is that x can't be negative anyways. It already put a domain restriction on x, so you don't need the absolute values. If you put the absolute value, it is fine, but it is not needed. Because in the directions, it already told me x can't be negative. So that's what it says when it says assume the variables are non-negative. It means that if you bring out an x squared as an x, x cannot be negative, so you don't need your absolute values. And then in the last one, you have to distribute the square to both the number and the variable. And again, take your square root. If you had 5 absolute value of x, that's fine. 5x is also fine. So we are going back to square roots. We're going to talk about them today, tomorrow, the rest of this week. We're also going to look at them as we get into the rest of chapter 5. So simplifying them is going to hopefully kind of reconnect, come back, and you'll recall December. So for this week, we are really focusing on complex numbers. The complex numbers are the set of real and imaginary numbers. So a complex number is the real and the imaginary. The imaginary part is the new piece to us today. So if you have x squared, I know what's going to happen, plus 2x, 4, go ahead and graph that real quick. So go ahead and graph x squared plus 2x plus 4. Remember that h, comma, k, and c are your y-intercepts and your vertex. So getting our graph, what we should notice about our graph, again, h is at -1, 3. My y-intercept is at 0, 4. So I also have the point at -2, 4. And I also have my other point at -3. And it's going to be up 4 and 1 over 2. So at negative 3, 7, and at 1, 7. So this graph, if you look at it, has no real solutions. It does not cross the x-axis. So part B says, what do you notice about the x-intercepts? What do you notice about the equation x squared plus 2x equals 4? So those are all the same. What does that tell me about the solutions? Well, the equation will never equal 4. It is not factorable. There are no factors of 4 that sum to 2. So there is no solution. There are no x-intercepts. Therefore, no real zeros. So how does that come into play today? Why am I going back? Why am I talking about quadratics not crossing an axis? What does that have to do with the complex numbers? Well, the complex numbers are these imaginary real solutions. So when we have no real solutions, we have now what we are going to call imaginary solutions. And I have to just flip up. We can go back to time. There's complex. Sorry about that. Okay, the complex numbers is the set of numbers consisting of imaginary and real numbers. So down below, I gave you a graphical example of what that means. So we had the real number system, which is off to the right side of that chart. And now we're adding to it the imaginary numbers. So the real numbers are on the right side of that chart, or on the left side of the chart. The imaginary numbers are on the right side of the chart. And together, they make up the complex number system. So the complex number system makes up the real and the imaginaries. And these happen when we take a square root of a negative. These happen when we take the square root of a negative. So in math, we use the letter I. Amazingly, it's logical. I for imaginary. We use the letter I to represent the imaginary numbers. I, in its most basic form, represents the square root of negative 1. I, in its most basic form, represents the square root of negative 1. So again, imaginary numbers are square roots of negative numbers. Imaginary numbers are the square roots of negative numbers. So we're going to have perfect imaginaries. We're going to have non-perfect imaginaries. The properties of complex numbers are the same properties that we have going into or talking about other numbers. So the properties of the imaginaries are the same properties that we have for other numbers. So we'll talk about what I mean by that. i's that I'm introduced to. Okay, find the additive inverse of each complex number. What's wrong? Just the word imaginary. I mean, the rest you kind of know. Here, hold back up. So again, imaginaries are on this side. The real numbers are on the other side. And if you remember, it goes full, natural, integer, fractional, and then the whole system is the reals. Yeah, no problem. All right, so finding the additive inverse. Literally, additive inverse means opposite. So what is the additive inverse? It means what can I add to this so that they equal 0? So if I wanted 7 to become -7 or -7 to become 0 with another number, you're going to add its opposite. So to make -7 minus 9i equals 0, we are going to add +7 plus 9i. So the additive inverse is 7 plus 9i. You'll notice with my i's, I put a little curl on the end. That's so you don't make like a confusion to your i's with like a number or anything else. So i's, when we write them, we put like a little curl to them. Opposite of -5i is +5i. The opposite of 4 minus 3i is -4 plus 3i. Just like we write standard form for quadratics where it goes x squared x, then c, standard form for complex is real plus imaginary. So you always write the real numbers first and the imaginary to follow. In this case, the real is 0. So like -5i, the real part is 0. -a minus bi. So again, real plus imaginary. So thinking back to the warm-up, we had square roots. Well, now we have square roots, but all of my square roots have negatives. So all of my square roots have negatives. So what happens is we think of these new problems by changing all of the negatives immediately to an I. So we're going to think of all of these problems as the square root of -1 times the positive square root of 54. And we said, by definition, the square root of -1 is now I. So you're going to change that square root of -1 to an I. And then you're going to go back to what we talked about before. We're going to say, okay, 54 breaks down into what perfect squares? So you would break 54 down into 9 and 6, because 9 is my perfect square. So you simplify that, so the square root of 9 becomes 3. So I get 3i square roots of 6. So all the simplifying radical parts stay the same. That negative becomes an I. If you have a prime number in your radical with that I, you bring out the negative as the I, and it stays square root 2. So I have I square roots of 2. The minute you have your negative, you bring it out as an I, and then you simplify your radicals. So 12 is 4 and 3. 4 becomes 2 on the outside. So I have 2i square roots of 3. We can also have perfect roots with i's. So again, that square root of -1 becomes I. leaving you with the square root of 36. 36 is a perfect square, so you get 6i. In the next part, we want to write the complex number in standard form, meaning a plus bi. So in all of these examples, the square root came before the whole number, so we would simplify the square roots. So negative 121 would become 11i minus 7. But that's not in what we call complex number form because the real part came after the imaginary. So we want to rearrange our terms so that it is the real plus the imaginary. So in number 2, same idea. We're going to flip the 7 to the front. We're going to simplify the square root by bringing out the I. We're going to say 18 is 9 and 2, so the square root of 9 becomes 3, leaving root 2. In number 3, the square root of negative 25 becomes 5i. The 7 does not combine. They're not like terms. You can add i's to i's, just like you can add an x to an x. You can add numbers to numbers, but you can't add numbers to i's. So that leads into the last bit for today, which are the powers of i's. The powers of i's are cyclical, meaning that they follow a pattern. So we're going to work through that pattern first to see what it is, and then use it on all the other powers of I. We already know, or should hopefully think we know, what I represents. So I is now forever ingrained in your brains as the square root of negative 1. If you have a square root and you can make a negative 1 inside, you turn it into an I. They're interchangeable forever. So that leads to I squared. So if I is the square root of negative 1, I squared would be like the square root of negative 1 squared. And what do we know about a square root and a square? They cancel out. So I squared equals negative 1. I cubed is really kind of the same as saying I squared times I. Because the rule is that if you have two things multiplied together, you add their powers. So if you have two things multiplied together, you add their powers. So if I squared is negative 1, we're going to replace this with negative 1. And that gives me negative 1 times I, which is really the same as negative I. You don't have to write the 1. I to the 4th could be done 2 ways. You could think of I to the 4th as I squared times I squared. You could also think of it as square root negative 1 squared, power to a power multiplies to give you that 4th. Either way, I get negative 1 times negative 1, or I get negative 1 squared, which means I to the 4th is 1. So remember I told you that i's are powers and then they're also a pattern and cycle? So they happen in cycles of 4. So after I to the 4th comes I to the 5th. So again, go back, look at the rules we just said. I to the 5th could be any combination of these put together. You could treat it as I cubed and I squared. You could treat it as I to the 4th and I, which is probably my favorite, because what do you know about I to the 4th? It is 1. So I to the 5th becomes I, which is really the same as I to the 1st. And guess what? I to the 6th is going to be the same as I to the 2nd, which means I to the 6th is negative 1. Because again, it would be I to the 4th and I squared. I to the 4th is always 1, so I squared is negative 1, so I to the 6th is also negative 1. I to the 7th is negative I. I to the 8th is I to the 9th is I to the 10th, I to the 11th, I to the 12th. Therefore, I to the 13th is I. So what are we looking for then? How do I simplify these? I'm looking for multiples of 4. Because every multiple of 4 is going to become a 1. So then you just have to say, okay, how many numbers past the multiple 4 is it? So 13 is 1 past the multiple of 4, because 12 is multiple of 4. So 1 past becomes I. $11 is how many past a multiple of 4? So what's the closest multiple of 4 in your 11? 8. So how many past 8 is 11? 3. So I to the 11 is the same as I cubed. I cubed is the same as okay, 91. So again, go through your multiples, right? The easiest ones are 4s. So you go 80, 84, 88. So 88 is like 1. So how many past 88 is 91? 3. Therefore, this is the same as negative I. $244. Ends at 4. Probably a multiple of 44. If you don't know, you can always divide it by 4. Oh, it is a multiple of 44 because it divides perfectly I to the 244 is 1. Ten is 2 past the multiple of 4, therefore it's the same as I squared, therefore it's negative 1. Now, do not be fooled. Can you add x to the 6 plus x cubed? Are they like terms? Are x to the 6 and x cubed like terms? Then neither are I to the 6 and I cubed. I to the 6 and I cubed are not like terms. Just going to move that up higher. See. You have to simplify them separately. So I to the 6 is I squared, which is negative 1. I cubed is negative I. So I to the 6 plus I cubed becomes negative 1 minus I. You have to simplify them separately. You cannot add i's together. They are separate. They are like terms, like variables. I promise once you practice them, like they start to click. Your homework, because this is like 3 pages, it's not front and back, it's like the next few pages. Some of your notes are like odd numbered this week, so I just want to make one nice packet, but therefore I can't say front and back, it's like back and front. So you're going to do the back and front of the next page on there. For powers of I, just look for that multiple of 4 and find how many it is after. Make sure for additive inverses, you have them in real plus imaginary form. And again, not every simplifying problem has an I in the